Here we have question 6, and the question has very kindly told us that this is problem solving. Okay, and we should always draw a sketch. All right, well, even if you didn't have that, always vector questions. They're very visual, they're lots of triangles. You've got to always draw a sketch. Okay, so we've got a trapezium, okay, with AB parallel to DC. Okay, so that's just AB. This could be our DC. Okay, DC is 3AB. Okay, so this helps. 3 times as big, but kind of read ahead before that. Okay, M divides DC such that D to M is 2 to 1. Okay, so this is M, this will be D, this will be C, and this is now in this 2 to 1 ratio. Okay, so A to B is going to be labeled A. All right, so let's replace this. A and B. A to B is A, and then B to C is B. Okay, and then we'll just connect this here. Find in terms of A and B, A to M, all of these. Okay, perfect. All right, so we've got one more bit of information. D to C is 3 lots of AB, so D to C is 3A. Okay, so as D to C is 3A, okay, D to M must then be 2A, and M to C must be A. Why is that? Well, it's in this 2 to 1 ratio. Okay, it's in that very important 2 to 1 ratio. So then we write this on our diagram, 2A, A. And we've got B there. Okay, now we've done our diagram, the question is going to be a lot simpler. A to M. Okay, A to M. Now, like every single question, okay, we do what direction are we taking? Well, we want A to M. Okay, so we go A to B plus B and then go back this way. Okay, what does this leave us with? Well, this leaves us with A plus B take away A. Okay, so that means that A to M is just B. Okay, next one, B to D. Okay, so where we start? Let's start with B and let's go to D. Okay, we're not going to go this way now because we don't have the information. Okay, that means we've got to go the other direction. Okay, so we're going to go down here and across here. Okay, so down B and negative 3A. Okay, down B and negative 3A. Okay, so that's our B to D. Now, what was that? M to B. What does M to B equal? M to the B is... Okay, M to B. So, start at M, we've got to go to B. Okay, yet again, we can't go this way. All right, because we don't know this. Okay, technically, actually, we could go here, here. Okay, but that relies on our previous answer being correct, by the way. Okay, and obviously our previous vector was correct. Okay, but we can't just assume that. All right, if there is another direction that works, always use that. Okay, to prevent lots of errors getting carried forwards. All right, so M to B is just A minus B. And now D, our final bit D. D to A. Okay, this final bit of information that's been annoying us because we didn't have, we can now figure it out. Okay, we're going to go back across this, well, not back across, sorry, across this 2A plus A again, so 3A, back up at B, and then take away A. Okay, so what was this? They wanted D to A, so D to A is, and people usually, I know throughout this I haven't been using the notation, but this is where you can break it down to say D to A is the same as D to C plus C to B plus B to A. Okay, and here you can kind of check D to A, you've gone D to C, C to B, B to A. So the overall effect is you've gone D to A. Okay, but that's what I'm going to cut out here in my workings out because when you get used to it, it's easier, I think, to think of it using this diagram. Okay, so what do we have? DC 3A, takeaway B, takeaway A. We go in the opposite direction. Both of those, this is 2A, takeaway B.